Hello and welcome to another session in physics. In this session, we'll be looking at the topic optical instruments. We'll be looking at the topic optical instruments. We'll be looking at instruments such as the camera, the projector, the simple and compound microscopes, telescope, human eye defects, and correction of vision. But before that, let us review our previous lesson. Welcome back. At this point, let's start with the first optical instrument, the compound microscope. But let me make it clear that the greatest of all optical instruments is the human eye. All other optical instruments you see today are produced or manufactured based on principles that have been discovered from how the human eye works. So scientists actually had to borrow a leaf from nature in order to manufacture all these other instruments that we use today. Already in our previous lesson, we've talked about the microscope. We've talked about the microscope and how it is able to magnify images and is used in the examination of biology specimens. Now, the compound microscope is a little bit more advanced than the simple hand lens microscope. The compound microscope is able to produce a greater magnification than the simple microscope. The simple microscope, the one we hold on our hand, that is handheld, that one has a limit as to the magnification it can produce. On the other hand, the compound microscope has a greater magnification. It has a greater magnification thanks to its double lens system. It has two lenses. If you've seen a compound microscope such as the one in the diagram here, you would notice that there is another lens here. It has two lenses here. So those two lenses, they are known as the objective lens. The objective lens is the first one, which has a short focal length, and we also have the other lens, which is the eyepiece. The eyepiece is used as the magnifying glass that helps to view an image that has been formed by the objective lens. So both of them work together. The objective lens and the eyepiece, they work together. So when the objective lens is able to find an object as a result of its short focal length, the eyepiece helps to magnify that object and is able to view the image that has been formed by the objective lens. The image formed by the objective lens is within the principal focus of the piece. It is within the principal focus of the piece. So a final image is formed at what we call the least distance of distinctive vision from the human eye. Take note of this term, least distance of distinctive vision of the human eye. What do we mean by least distance of distinctive vision? Least distance of distinctive vision simply refers to the minimum distance that an object can stay very close or away from the human eye, and the eye will be able to see that object and make it out without any strain. So for some people, for them to be able to see an object very well, they have to bring it very close to their eyes. At that point, we say the person has a very small least distance of distinctive vision, and it is an eye defect that we call myopia, as we'll consider in our next slide. On the other hand too, there are some people that for them to be able to see objects very clearly, they have to put it far away from their eyes. That is an eye defect we call hypermetropia or long-sightedness. For every normal human eye, we have what we call the least distance of distinctive vision. It is the minimum distance at which a human being or a human eye should be able to identify objects and make them out clearly. Before we come to the eye defects, let's talk about the astronomical telescope. The astronomical telescope is used basically for viewing objects that are very far away, such as stars and planets. It is used for viewing objects in space. In many ways, the astronomical telescope is very similar to the compound microscope because both of them have basically the same principle of working operation. Just like the compound microscope, the astronomical telescope has two lenses as well, the objective lens and the eyepiece. But the only difference between an astronomical telescope and the compound microscope is that an astronomical telescope, the objective lens has a long focal length, whereas for a compound microscope, we said that the objective lens has a short focal length because it is used for viewing objects that are very, very close to it. On the other hand, the astronomical telescope is used for viewing objects that are very far away from it. So this long focal length helps to form a real image of a very distant object at its focal length. The position of the eyepiece and the objective lens must coincide along the principal focus so that the final image that will be formed will stay at infinity. It's important to note that the astronomical telescope gives us what we call an inverted image, which of course can be tolerated when we look at stars, but when we're looking at objects on the earth, we are at a disadvantage. So, have you ever tried using an astronomical telescope before? Have you had an experience trying to look at heavenly bodies or stars at night, or trying to look at other planetary bodies that are constantly orbiting in our solar system? Then you have to know how the principle of operation is like. It has two lenses, the objective lens and the eyepiece. So in your examination, they would ask you to state the differences between an astronomical telescope and a compound microscope. Always remember that a compound microscope is used for viewing objects that are very close to the eye. That is number one. And on the other hand, the astronomical telescope is used for viewing objects that are very far away from the eye. Also, the compound microscope has a short focal length, but the astronomical telescope has a long focal length. So these are the basic differences. Notice too that when it comes to a compound microscope, the image that is formed is within the principal focus. But for an astronomical telescope, the image that is formed must be along the principal focus and not within it. Also, images that are formed by an astronomical telescope are inverted images, but images formed by microscope is not an inverted image. Now let's look at the greatest optical instrument in the world, the human eye. The human eye, as you can see from the diagrammatical expression here, has many parts. We have the sclera, we have the cornea, we have the pupil, lens, iris, ciliary body, optic nerve, fovea, retina, choroid, and of course we have the one we call the aqueous humor that stays somewhere at this point. Now these are all the parts that make up the optical system of the human eye. The most important are the cornea, the aqueous humor, the vitreous humor, and the lens. These optical systems help to form a real and inverted image of an external object on the retina. So the retina is the part of the human eye where an image is formed. Now this retina transmits that impression that has been created on it by the image through the optic nerve to the brain. So when the object is focused on the retina transmits this impression to the brain through the optic nerve. It is now left for the brain to interpret what it has received as an impression. It is the amount of light that enters the eye through the pupil that helps us to see either bright or dark objects. It helps us to see clearly or dimly. And the amount of light entering the eye is regulated by the part of the eye we call the iris. So get yourself acquainted with the parts of the eye and the functions that they carry out. Now let's talk about eye defects. Remember we said that long-sightedness is a situation where somebody is not able to see objects that are close to him, but he can see objects that are very far from him. It simply means that this person's near point is more than 25 cm. In other words, his least distance of distinct vision is more than 25 cm, and 25 cm is the normal least distance of distinct vision for the normal human eye. So this person needs to place objects very far away from him for him to be able to see very clearly. For us to correct long-sightedness, which is also known as hypermetropia, we use converging lens. This person. Also, The second eye defect is called short-sightedness, which is myopia. Sometimes, metaphorically, we say that someone is myopic. It means that the person cannot see too far ahead. The person is just focused on what is right in front of him. He cannot see the bigger picture. That is what happens to somebody who is suffering from myopia. The person can see objects that are very close to him, but the person cannot see objects that are far from him. He cannot see distant objects that are far from him. It means that his least distance of distinct vision is too close. It is less than 25 cm. For us to be able to correct short-sightedness, we should use diverging lens. We use diverging lens. Diverging lens makes the object at infinity appear to be at the person's far point. So this eye defect is corrected. And that's it for today. Thank you so very much for joining us in this lesson. To refresh your memory on what we just discussed, please take the test that will appear on your screen.